In this video, I will be providing some of the fundamental concepts of capital budgeting. Let's start with our problem. Our problem states that we have two mutually exclusive projects with the following projected after-tax cash flows. The problem continues to ask us to calculate the payback period, the discount payback period, the net present value, internal rate of return, and the modified internal rate of return for each of the projects. Let's start with calculating the present value of these cash flows for Project P. We'll start by simply saying the Project P, if we're going to invest in a project as of today, that would be equal to time period 0. So a cost of $15,000 today is equal to a cost or equals negative $15,000. However, if Project P is expected to have a cash flow of $4,500 1 year from now, discounted at 14%, we know that this $4,500 is going to be somewhat less than $4,500. So here we want to use the present value function. So let's click the insert function icon, type in PV, and hit enter 2 times. Our rate of return is going to be equal to the 14%. And let's go ahead and use the absolute referencing, or if we hit the F4 key, the number of periods is equal to 1, and the future value is equal to $4,500 in time period 1, and click OK. Now notice that this shows up as a negative. Let's change that to a positive. And so let's put a minus sign in front of the present value function and hit enter. So $4,500 1 year from now, discounted at 14%, is equal to $3,947. Now we can go ahead and copy that formula down, and if we click on the auto sum, notice that it's grabbing everything that we need, and even though it's grabbing this extra cell here, there's nothing in there, so we can simply click on the auto sum column or the auto sum command 2 times real quickly, and it's going to provide the total present value of these cash flows. Let's do the same thing for Project Q. Say equals negative $37,500. The cost is the cost as of today. Now let's use the present value function. Type in PV, enter 2 times. Our rate is equal to, click on the 14%, and once again, using the absolute referencing, the number of periods is equal to 1, and our future value is equal to the $11,100, and hit OK or click enter. Let's change that from a negative amount to a positive by increasing or by entering the negative sign in front of the present value function. Now we can copy that down and just real quickly click auto sum 2 times, and notice that the present value of all of these cash flows is in total, discounted at 14%, is $607. That same amount is equal to what's called the net present value. The net present value is the true value of a project based on your required rate of return. Now, Excel has an NPV function, so let's give that a try. Click on the insert function. And let's go ahead and type in NPV and hit enter 2 times. Our rate of return is equal to 14%. And our values, if we click in the values box and then just simply highlight the cash flows and click enter. Notice that the net present value does not equal the total net present value we calculated over here. I'm not sure why Microsoft Excel or Microsoft created a function that doesn't actually work, but in this case it happens to be a function we need to adjust slightly. So let's go up into our formula bar and type in times or an asterisk in parentheses 1 plus, and click on the required rate of return, or 1 plus the required rate of return, and close our parentheses and hit enter. So our net present value, or the value of our project, is $450. Let's do the same thing for project Q. Click on the insert function, NPV, required rate of return, our values, highlight the values, and hit enter. And then go ahead and enter back into the formula bar, multiplied by, in parentheses, 1 plus, then click on that required rate of return one more time, close our parentheses, and hit enter. So our net present value is $450 for project P, $607 for project Q. In this case, if we had to choose one project or the other, and that's what the term mutually exclusive means, is that if you select one, you're going to exclude the other. Simply based on our net present value, we would accept project Q and dismiss project P. So you might be thinking to yourself, if the net present value or the value of this project is really $600, would you really invest $37,500 in order to make $600? That really doesn't make sense. But keep in mind that the $607 is relevant to the required rate of return. If in the case, say that if we got a bank loan to fund this project, we need to make at least 14% to pay off the interest on this $37,500, and then we would need to make something above 14% in order to make a profit. Well, that's the idea of the required rate of return. However, let's think about this differently. What if maybe our required rate of return was only 5%? If we change that to 5%, notice how much more profitable that makes these particular projects. So that's one of the things to keep in mind, is that the net present value or the profitability of a project is really highly dependent upon the required rate of return. If we require all projects must meet or exceed a 5% rate of return, well then you have a relatively low threshold to becoming profitable. However, if you had a relatively high threshold, let's say that we had a required rate of return of 25%, well, that makes it much more difficult for a project to be profitable as measured by the net present value. Let's go ahead and go back to our initial required rate of return of 14%. The next method capital budgeting method we're going to look at is called the payback period. In calculating the payback period, I find that it's handy to create a cumulative cash flow. And the way that works is, let's go ahead and just say equals and click on the negative 15,000 and hit enter. Now let's say equals the accumulating column here, or the cumulative amount, plus the $4,500 from time period 1, and hit enter. And then, now that we've done that, let's go ahead and copy that down. You can see that after 1 year, we've gotten some of our $15,000 back, but not all of it. After 2 years, we've gotten some additional money back. After 3 years, we've got almost all of our money back. After 4 years, between 3 and 4 years, you can see that we have our payback. So our payback then is going to be equal to the time period of which is right before payback is achieved. So in time period 3, time period 4, we're going to click on time period 3, plus, in parentheses, now we need to change this negative 1,500 to a positive, so go ahead and type in negative, and then click on the 1,500 divided by the cash flow in the year following, or in the year in which payback is achieved. So that's the cash flow in time period 4. Close our parentheses and hit enter. you can see that our payback period is 3.3 years. Let's do the same thing for project Q. Equals the negative 37,500. Hit enter. Equals, click on the 37,500 in our cumulative column plus the 11,100 in time period 1. Hit enter. And then go ahead and copy it down. We can see that payback is achieved between time period 3 and time period 4. So we're going to say down here equals, click on time period 3, it's the year of which payback is achieved, plus, in parentheses, we need to change the negative 4,200 to a positive number, so click minus, and then click on the 4,200, divided by the cash flow in which payback is achieved, so cash flow in year 4, close our parentheses, and click enter. You can see that our payback for project Q is in 3.4 years. Now, so we can say equals 3.3 years and equals, and then just click on 3.4 years. Okay, continuing on, the next concept here is we looked at that, gosh, project P has a payback period of 3.3 years. But the problem with the payback period is it doesn't factor in the time value of money, because $4,500 4 years from now or 3 years from now is not equal to $4,500 today. So we lose the time value of money context in the payback period. So one way to fix that is to calculate what's called the discounted payback. We're going to calculate the payback period based on the present value of these cash flows. Okay, so let's do it. Equals, click on the negative 15,000 in the present value part of the table and hit enter. And say equals, click on the 15,000 from above plus the 3,940, plus the $3,947 and hit enter. And then go ahead and copy that down. So now you can see that the discounted payback is actually achieved between years 4 and 5. So let's calculate our discounted payback. Equals the time period right before payback is achieved, or 4, plus, in parentheses, and once again we need to change this negative 1,888 to a positive, so let's type minus and then click on the minus 188. A negative negative is a positive. Divided by, and then we're going to click on the cash flow or the discounted cash flow after year 4, so discounted cash flow in year 5, and close our parentheses and hit enter. Therefore, our discounted payback period is 4.8. So ultimately, we know that the payback period is 3 years, but because of the time value of money concept is ignored, the discounted payback period is a much better tool for analyzing the profitability of a project or analyzing the risk, because ultimately that's the ultimate usefulness of the payback period. Let's calculate the discounted payback for project Q. Equals the minus 37,500, hit enter. Once again, equals minus 37,500 plus the 9,373, hit enter, and then go ahead and copy that down. We can see payback is achieved sometime between year 4 and year 5. So our payback is equal to, click on 4 years, plus, in parentheses, and then once again, we need to change the 5158 to a negative. So minus, click on the negative 5158 divided by the cash flow, discounted cash flow in the year following, so year number 5. Close our parentheses and hit enter. Our discounted payback period is 4.9. So if you really think about it, that's a pretty significant difference between the payback period and the discounted payback period. Let's go ahead and fix up our table just a little bit. Equals 4.8, and then over here equals 4.9. If we want to fix this up just a little bit more, let's go ahead and highlight these items, and let's just stick to, say, highlight those two, and then click on the control and highlight these two, and then right click, click on Format Cells, and on the custom, I scroll all the way up to the top, just about, let's click on 0.0. Click up in here, I'm going to backspace over the 0, and I'm going to use my quotation marks, space, and type in years in quotation marks. So I have 0.0, quotation mark, space, years, and quotation mark, and hit OK or Enter. And notice that that just added the labels to the data that we have. Continuing on, one of the problems with the net present value concept is that it doesn't really follow management speak, so to speak. And let me give you an example. Let's say that project P is a conveyor belt and project Q is buying a truck. And somebody is asking, well, what did your analysis of the truck result in? And I might say, well, the net present value of 14% came out to be $607 based on a required rate of return of 14%. In general, that's not the way people talk. In general, you might expect to hear something like, well, the rate of return on the project is estimated to be 15%. Okay, that's something of which most people might be able to relate to a little bit more than the net present value was $607 based on a required rate of return of 14% over a 5-year period of time. That's not something most people are going to be comfortable with. So another way to analyze a project that is based on the rate of return concept is something called the internal rate of return. Let's do it. Let's go ahead and click on the insert function and go ahead and type in IRR and hit enter 2 times. And then all we have to do is highlight our values and hit enter. In this case, the internal rate of return, or the rate of return on the project, is 15.2%. Very easy to calculate, at least in Excel it is, and it's something of which people can relate to a little bit more. Let's do the same thing for project Q. Click on IRR, highlight our values, and hit enter. Notice that the internal rate of return is 15.2% for project P and 14.7 for project Q. Now wait a second, we said that earlier we would accept project Q because it had a higher net present value. Well, in this case, which do we select? Well, because of the size differences between project P and project Q, we come up with what's called a ranking conflict, and where the net present value values the project Q more highly, while the internal rate of return values more project P a little bit more highly. In this case, anytime you have this type of conflict, we simply default to net present value. Net present value is the better analysis, and so that's the one that we would choose. One of the other problems, though, is that say that you said, gosh, well, project Q has the better rate of return, or project Q has a rate of return of about 15%. One of the problems with the internal rate of return, it assumes, the methodology assumes that all of these future cash flows can be reinvested at 14%. That may or may not be true. One of the ways to eliminate that bias of a project or that problem with the internal rate of return methodology is to use the modified internal rate of return. So let's do that. We have the insert function, Let's go ahead and type in MIRR and hit enter 2 times. So our values is equal to, once again, just highlight the values and hit, oh, excuse me, my mistake. Okay, so I have the values highlighted, and let me make sure that those are correct. Now the financing rate is 14%, and the refinancing rate, now we're going to assume 14% and click OK. Okay, so our modified internal rate of return ends up being 14.7% as compared to the 15.2%. And excuse me, I made a mistake earlier when I said the IRR assumes that the rate that these cash flows can be reinvested at 14%. I should have said that it assumes that these cash flows can be reinvested at 15%. That may or may not be true. So here we're saying the required rate of return is equal to the reinvestment rate assumption. If the reinvestment rate assumption ended up being maybe 10% or something less, it would reflect in a lower modified internal rate of return. If the reinvestment rate assumption was higher than the 15%, then the modified internal rate of return would be greater than the 15.2%. So I apologize for that mistake. Finally, let's make one more calculation here. The modified internal rate of return, our values, finance rate, the reinvestment rate assumption we're assuming is 14%. It could be different, but we're just going to use 14% and click OK. Because the reinvestment rate assumption is a little bit less than the internal rate of return, the modified internal rate of return is going to be a little bit less as well. So in this case, we can say which of the projects should be selected. We see that number one, we want to use the net present value methodology. Project Q should be selected. If they are independent projects, means you can accept project P, you can accept project Q, you can accept both of them or neither of them. Both of these projects have a rate of return of greater than 14%, and they have a net present value greater than 0. That's the test. If a project has an NPV of greater than 0, it should be selected. So in this case, both project P and project Q should be selected. That concludes the overview of the capital budgeting models and functions and some of the initial concepts. And I will talk to you again in some future videos.